Hello and welcome to the Tour of the Universe series. I'm your host, Michael Albrecht. Glad to be with you today. These are difficult times we're living in and hope you all are doing well. Today we're going to be starting the Tour of the Universe series by taking a look at the US-Russian space race from the 1940s to the present. And we'll see that space race, which covered a lot of the decades of your life in the 20th century, the mid to late 20th century and to the present, involved a lot of competition and cooperation between the two superpowers. And so it's a fascinating topic and covers a lot of events that many of you probably remember, events and people, leaders, and so on that really contributed to the drama of getting into space. We see the idea of going to the stars has been around since the Roman era and probably the beginning of human beings a couple million years ago. The famous phrase per aspera ad astra, meaning through hardship to the stars, is borne out in the space race between the Russians and Americans. And we'll see that the human desire to go to the stars has been with us forever. Carl Sagan, the famous astronomer from Cornell University, famously quoted saying that human beings are made of star stuff, that life itself on Earth is made of star stuff. And what he meant by that was that the elements in our body were forged in the previous generations of stars. All the elements that we know of, hydrogen, oxygen, phosphorus, nickel, iron, and so on, all the elements that make up our body, carbon, the basis of life on Earth, were forged in pre-existing stars that went on to form our solar system, our sun, and the planets as we know them. So it's natural that we want to reach out to the stars to understand our place in the universe and also feel a certain longing to get out there into the stars, as we see in this wonderful photo here from Finland in the 1800s. Per aspera ad astra, through hardship to the stars. And we will see that borne out here in the history that brought us to the modern era. Beginning with Nikola Tsiolkovsky in Russia and Hermann Oberth in Germany, Robert Goddard in America, and other rocket scientists. Through the late 1800s and into the 1900s, these gentlemen were developing different kind of systems, rocket systems that would be able to lift objects and humans off of the surface of the Earth and into orbit around the Earth and out to the moon and to the planets and beyond. That involved a lot of advancement in technology in terms of fuel and multi-stage propulsion systems. The US was so interested early on in aviation and rocketry that in 1915 it established the National Advisory Committee on Aeronautics, the NACA. Some of your parents were probably familiar with this, and certainly the Wright brothers flight early on in the 1900s. Here we see the board. Looks like I'm on the board, by golly. We see the first board of directors of the NACA in Washington in 1915. The NACA evolved through the 20th century to the 1950s, when the National Aeronautics and Space Act of 1958 created NASA from the NACA. And here we see NASA headquarters in Washington, D.C. The Russians simultaneously were developing a very robust rocketry program in the 1940s and beyond. Those programs are actually scattered around the various Soviet republics, especially in Kazakhstan. And when the Soviet Union fell apart in 1989, A few years later, Russia consolidated and centralized its space program into what's known as the Roscosmos State Space Corporation, which is headquartered here in Moscow. So you have both the Americans and the Soviets with major, now centralized space programs. The ultimate goal in the 1960s, of course, was to put a man on the moon, which ultimately occurred in July of 1969. And we see here the culmination of that effort through the 1960s with Buzz Aldrin on the moon, photographed by Neil Armstrong. But getting that man on the moon involved employing the technologies that the Germans and the Nazis had developed in World War II. And here we see the central figure in the US space program and the Nazi space program, the Germans in the 1940s, who was Werner von Braun. And he was a member of the Nazi Party. You pretty much had to be, or you would have probably been killed or at least thrown out of the country. So Werner von Braun was indeed he was a German. He was a member of the Nazi Party, which you had to be. And he helped develop the V2 rocket, which stood for the Vengeance Weapon 2. In the Nazi convoluted thinking, when the Allies, the French and the English, were defending themselves against German aggression, Hitler saw fit to claim he was defending himself and seeking vengeance against their own protections. In any event, we know how convoluted history can be and politics. The V2 rockets developed by Werner von Braun really wreaked havoc, of course, on England and Belgium primarily in the 1940s. And here we see the results of some of that destruction in England. Again, the V2 rocket developed by Werner von Braun and the Nazis required new technologies, new propulsion systems, new fuels, new navigation and avionics. So von Braun and his rocketry team were expert. They were expert engineers at developing these new systems. Here we see VE Day, Victory in Europe Day, with Winston Churchill declaring victory on May 8th, 1945 to the crowds. Shortly after that, Werner von Braun was captured by US forces in Germany. What's interesting is, of course, that as the war was approaching its close in 1945, both the Russians and the Americans and the British went into Germany to try to retrieve as much of the expertise in the rocket scientists, the German rocket scientists, their technology, the equipment, the hardware, their blueprints. And we see a lot of that culminated. There was discussions here in Potsdam in July of 1945. And there you see this famous photo with Churchill, FDR, and Joseph Stalin in Potsdam, Germany. A lot of details. The devil is in the details. So the results of this summit between these leaders left a lot of room for suspicion and disagreement and conflict in the future. So again, at the end of the war, the Americans, the Russians, and the British swooped into Germany and acquired as many of the scientists as they could, the rocket engineers, the blueprints, and the hardware. This photo captures Werner von Braun standing there with his arm, his hand in his pocket here in the front. And there are intermingled in this group many German rocket scientists out in Fort Bliss, Texas, is where they were originally taken. This photo was taken in August of 1946, just barely a year after the war ended. And so you have a mix here of German and American rocket scientists, officials, and so on, who are out there in far west Texas, outside of El Paso. And they were working near the White Sands, New Mexico rocket test site, where they developed a new version, basically, of the V2 rocket. And here you see on the left a version of that V2 rocket, which is now on American soil. And on the right, you see what's considered to be the first photograph taken from suborbital space, basically. They shot one of these rockets up and had a camera on it and took a picture back at Earth. That's considered one of the first photographs from space, looking back down on the clouds and land of Earth, as Earth itself is traveling along at about 67,000 miles an hour around the sun. So von Braun and Hermann Ohlberth here in the foreground, they were transferred from the Fort Bliss site over to the main NASA, what was still then NACA, the rocketry development site, Army Ballistic Missile Range in Huntsville, Alabama. And here you see Hermann Ohlberth in the foreground, and there is Wernher von Braun looking very determined at the camera with the rockets. So all of this had been set into motion at the end of World War II. Harry Truman, of course, the president who took over from FDR in the mid to late 1940s, Truman was not really aware of that the U.S. was bringing in a lot of German Nazi rocket scientists. And they tried to basically shield Truman from knowing about this so that he didn't feel he was compromised. They knew that this would be a significant, potentially could have been a significant public relations difficulty to bring in Nazis to help with the US space program. But that's exactly what was done. As we were bringing Wernher von Braun and his team over here to America, the Russians were doing the same thing. So they, Lieutenant General Vasily Voznik, he was the team lead for the Russian space program, and along with Sergei Korolev. These were two Russian rocket engineers, designers. Korolev actually had been thrown into prison by Stalin in the 1930s, and later was determined to be a brilliant rocket designer, so they pulled him out of the Gulag in Russia. He had been thrown in for basically insubordination and trumped up traitor sedition charges against Stalin. In any event, those are the two main leads of the Russian space program, Voznik and Korolev. They brought in Russians, among them Helmut Gottrup, a rocket scientist, and he was brought in to lead his team of German rocket scientists to work with the Russians on their space and rocketry program. So here you have this fascinating setup where we have cannibalized the German rocket engineers into both major countries, Russia and America, and we're trying to now build space programs around them and get into space first. Finally, the Soviets beat us to getting the first object in orbit with Sputnik, which I'm sure many of you remember as younger persons. In October of 1957, there's the New York Times heralding it. And in the center there, you see a photograph of taken actually at the Texas State Fair in October 1957, where a group of people are listening to a ham radio, and they're listening to that famous beep, beep, beep of the Sputnik going overhead in orbit. So the Russians beat us into space. They had their problems. Come 1960, the Russians were experimenting with a rocket liquid fuel that exploded on the launch site and killed nearly 200 technicians, but more importantly, high-ranking officials and rocket engineers in Russia. So this set the Russian space program back significantly and may well have contributed to the US being able to get to the moon first. But nonetheless, they were able to launch Yuri Gagarin into space on April 12th, 1961. And there's Gagarin. So the Russians were able to beat us with the satellite Sputnik and Yuri Gagarin. Here's the Huntsville Times in Alabama. Man enters space. An incredible race going on here. The Russians also were the first to launch a cosmonaut, a female, into space in June of 1963. It wouldn't be till 20 years later on a US space shuttle launch that we sent our first females into space. The Russian workhorse rocket was the Vostok, which is actually still in use today and has been used while the space shuttle program was down this past decade to ferry US astronauts up to the International Space Station. Another German rocket scientist who came to the US was Kurt Debus. He was the first director of Cape Canaveral in Florida in 1962. He was also a Nazi, a German rocket engineer who probably had to be a member of the Nazi Party. But here we see him with Kennedy in 1962 at the establishment of the Cape Canaveral, the launch facility in Florida. It's incredible to think about how history is so interwoven on itself that I guess to the victories goes the spoils, and so the victors. And so the Americans and Russians both benefited from the German space program and their engineers. Alexei Leonov was the first human to walk into space in 1965. So the Russians were always ahead of the US at these major milestones, even though they had their significant setbacks, such as the explosion of that rocket. Just a couple months later here, this is March 1965, Alexei Leonov, first human to walk into space. And then in June 1965, Ed White was the first American to walk into space. And here he is, Ed White, about 150 miles up in orbit and orbiting the Earth at about 17,000 miles an hour, the first American human satellite in orbit around Earth. And you can see the beautiful planet in the background. NASA had a long series of rocket failures in the early to mid 60s, which set us back. Wernher von Braun was continuing his efforts at the Marshall Space Flight Center that had developed out of the Army military facility there outside Huntsville. Werner Dahm, another German rocket scientist who came and joined von Braun. He had been working with von Braun in Germany on the V2 project. In 1979, backing up a little, we had announced the first Mercury astronauts, the original 7. And here we see the whole original crew: John Glenn, Gordon Cooper, Deke Slayton, and Alan Shepard, and so on, April 1959. And all of these gentlemen, pilots, mostly test pilots, Navy, Air Force pilots, became astronauts and went into space on various flights. Before we sent our first astronaut into space, however, we sent a monkey, Ham, the monkey, in January of 1961. He made it up and back. The Russians also had been sending animals. They had sent dogs into space, lost a number of the dogs, but some of them survived. Finally, in May of '61, Alan Shepard aboard Freedom 7 took off from Cape Canaveral, and he basically went across the Atlantic Ocean from one side in Florida over to off the coast of Spain. Next was Gus Grissom, the second American in space in July of '61, and Liberty Bell 7. These are all, this is through the Mercury program still. And so Gus went up and famously came down in the Atlantic Ocean. And let's see, yeah, he came down and blew the hatch. The hatch blew. It's actually was later determined that it was a mechanical failure. But Gus Grissom, suffered considerable embarrassment because it was believed he had accidentally or deliberately blown the hatch and lost the capsule, the Liberty Bell, which sank to the bottom of the Atlantic Ocean, which was later recovered, and they were able to study it, examine it, and determine that it was a mechanical failure and not Gus. Sadly, Gus went on with Ed White and astronaut Chaffee to die several years later in the fire of Apollo 1 on the launch pad, a test run of the Apollo 1, which I'm sure we all remember. John Glenn became the first Mercury astronaut in orbit, February 1962. Kennedy speaks to Congress in May of '62. In the background, you can see LBJ on the left and Sam Rayburn, Speaker of the House. So the effort to get to the moon and put Americans on the moon was gaining steam starting in the early 1960s. The Russians had their eye on the same goal. There was a second group of US astronauts in September of 1962 announced. The next year, Kennedy came to Rice University football stadium and gave his famous speech about going to the moon before the end of the decade. You can see Johnson, LBJ in sunglasses and the stands behind Kennedy there. This is, of course, just a few months before Kennedy was killed in Dallas. The first Gemini launch involved Gus Grissom and John Young in March of 1965. It was the first time the Americans had sent 2 astronauts in orbit. And you can see the little capsule up there, the little black capsule at the top of the rocket. And there are the 2 astronauts. 1965 about, here's LBJ at the Houston Space Center. It was later renamed the LBJ Space Center down outside of Houston in Clear Lake. But here is LBJ with some of the Gemini astronauts. Of course, LBJ had been instrumental in both the passage of the National Aeronautics Space Act in the late 50s and also establishing the site down in Houston. Johnson thought that getting Americans into space was an imperative. And so he basically convinced Kennedy to pursue that. And after Kennedy was killed, Johnson vigorously pursued the space program as president. Here are the launch pads in the 1960s during the heyday of Cape Canaveral's vigorous activity. Look at the number of launch pads there on the Florida shores of the Atlantic Ocean. What a dramatic scene that must have been. Here's a great shot of Wernher von Braun in the center there, looking at a test of the Saturn V rocket there at Cape Canaveral. So here you have a former German rocket scientist at the center of the American space program. Strange bedfellows, indeed. Sadly, in January of 1967, we suffered our worst loss of these 3 astronauts when there was a fire aboard Apollo 1. January 1967, there was a treaty for outer space that established some general rules and parameters to try to provide some structure to this competition and the cooperation that was going on between the Americans and the Russians, the Outer Space Treaty. It provided some guidelines and later provided a blueprint for a future treaty as well, which basically involved non-militarization of space, assisting each other in times of a disaster or breakdown of a spacecraft in orbit or on the moon. So there were various points laid out here to try to establish some cooperation between the superpowers. The Soviets had their continuing mishaps while they were having great successes. Vladimir Komarov died in 1967. He was well loved in Russia. Crash landed in Kazakhstan. Apollo 8, December 1968. Our first run to the moon, it was a test run to make sure all the systems were go in December of 68. And here is that Apollo spacecraft on the Saturn V rocket being rolled out for launch in December. Here's the basic blueprint, the design, showing how the spacecraft launched in Florida, went around the Earth once or twice, and then used the Earth's gravitational field to slingshot off to the moon. It took about 3 days to get to the moon, went around the moon once or twice, and came back. In the process of that, they got this first wonderful picture of Earthrise, December 24th, Christmas Eve, 1968. And as the Apollo 8 astronauts came around the moon, they took this wonderful photo of Earth rising in the blackness of space. Finally, Apollo 11, July 1969, on the launch pad, taking the 3 astronauts to the moon. Perhaps some of you were there. Certainly some of you were following it in the audience. We're following all these developments. I know my father was very interested in this, and it was a tremendous time for America to be sending astronauts to the moon. Here's the crew, left to right, Neil Armstrong, Michael Collins standing, and Buzz Aldrin. Michael Collins would stay in the command module while Armstrong and Buzz Aldrin went down and landed on the surface of the moon, got out and walked around for some hours, took pictures, set up some equipment and an American flag. And let's look at a little montage here of Apollo 11. I'm sure some of you in the audience watching this program watched this live while it was going on. It must bring back some wonderful memories. Here they are departing the moon. Hoping all that equipment works. Here they are splashing down in the ocean, getting ready to be picked up by the Navy. Well, if that doesn't fill you with pride, not only of being an American, but also being a human being. And in our lifetime, imagine that. We're the first generation to get off the planet and go to another object in space. Just a really privileged, wonderful time to be alive. So here is a photo of the moon showing the 6 landing sites that the Apollo astronauts landed on from 1969 to 1972. Apollo 11 through, behind me. Apollo 11 through 16 minus Apollo 13, which went out but wasn't able to land. They had a problem with an oxygen tank and were lucky to get back safely. So here's Buzz Aldrin on the moon. You can see Neil Armstrong taking the photo in his visor, July 20th, 21st, 1969. And so the astronauts, the NASA sent several more missions up there, collected rocks, took measurements. They also, looking back at Earth, got these fantastic photographs. Apollo 15, looking back at Earth. And there's our beautiful planet. It looks so pristine and peaceful. Makes you wonder what all the fuss is about here. The planet is very small, actually. It's only about 8,000 miles in diameter, 24,000 miles in circumference, and is hurtling along around the sun at about 67,000 miles an hour, as the sun itself is moving at about 500,000 miles an hour around the center of the Milky Way galaxy. So just incredible speeds and motions involved with our existence here on this little planet Earth. Apollo 17, the last mission on the moon, December 72. And here's the photo as the Apollo 17 astronauts are coming into Earth, this wonderful photo showing Earth in wintertime. And you can see how the northern hemisphere is tilted away from the sun. You can see Antarctica at the bottom, well exposed. That means it's summertime in the southern hemisphere, and it's wintertime in the northern hemisphere, which is leaning away from the sun. There's a plaque that was left on the moon by Apollo 11, signed by Richard Nixon and the astronauts. Here, man completed his first explorations of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind. Indeed, let us continue hoping for that. Meanwhile, the Russians were continuing their efforts. They had a disaster in 1971 when these astronauts, they landed safely, but apparently there had been a decompression in the capsule as they were coming down. They lost oxygen, and all 3 of these cosmonauts were found dead in the Salyut 1. Very sad. And meanwhile, early 70s, new cosmonauts were coming online, just as the NASA was bringing new astronauts online. Finally, in the mid 70s, the US launched Skylab, which was our first space station, basically. You can see here in orbit around Earth with its solar panels. An experimental, short-lived lab They ran some science experiments and tested various things. Finally, in 1975, the Russians and Americans had a joint cooperative project, the Apollo-Soyuz test project, July of 75. And here on the lower left, you see cosmonauts and astronauts in orbit together. They've linked up in orbit. Here's the Soviet Soyuz spacecraft approaching the Apollo spacecraft. So it was great to have some cooperation and see that while we may argue and differ politically and militarily, when it comes to science, countries can cooperate. Human beings can cooperate, and we often do on a scientific level. Here are the astronauts and cosmonauts that were part of the Apollo-Soyuz test project. Finally, the U.S. space program takes a whole new chapter with the launch of the space shuttle program in April of 1981. John Young and Robert Crippen avoid the space shuttle Columbia. The first female astronaut, 1983. Sally Ride on the right. Space shuttle Discovery now moving into the 1990s with the U.S.-Russian crew. More cooperation.
2, 1. Boost to ignition and liftoff of Discovery on a bold new era of spaceflight between the United States and Russia.
So here we are in orbit, the Russians and Americans doing science, photography. Wonderful. Meanwhile, the Russians put up their own space station in February of 86, the Mir, which stands for peace. So here you have an American on a Russian spacecraft being launched up to the Mir space station, the Russian space station in orbit. Wonderful. Great to see us all up there cooperating together. There's a shot of the Mir. Its solar panels arrayed. There's the Earth in the background. Space shuttle program ran from 81 to 2011. There was a new cooperative statement issued in 1987, which laid the groundwork for U.S.-Russian dockings in orbit.
It was a flight where there was a high degree of congressional interest because of the risk. There were questions about the Russian Mir space station that had the fire. Previously, they had the collision. And then a couple of days before liftoff, the Mir experienced another attitude control computer failure, and so they lost attitude control. So there were a lot of questions that we had to answer prior to liftoff regarding whether or not it was safe to go up to Mir.
But they did it successfully, and everyone was back safe. Sadly for the U.S. space program again, which I'm sure many of you, most of you remember, as the Space Shuttle Challenger disaster of January 28, 1986. And we see the astronauts on the left there, the 7 astronauts, and the results, apparently a O-ring in one of the boosters had frozen overnight and therefore did not expand and seat itself correctly to prevent the exhaust from coming out of a joint in the one of the booster rockets, and that caused a burn through, which caused that booster rocket to bend out and twist, and it caused a opening in the main rocket booster, which caused the explosion. So just the day before, they had attempted the launch and were ready to go. The weather was warm and sunny, and but they had had trouble with the getting the door closed, and just the smallest little mechanical failure the day before had caused the delay of one day, and overnight the cold front came through and caused that O-ring to freeze up, and that's what led to this tragic incident. The space station has been up in orbit now for over 20 years, almost 20 years, November 2nd, 2000. And that is another big international cooperative effort with the Americans, the Russians, and so many other countries, the British, the English, the British, the French, Japanese, Indians. There have been astronauts and scientists, engineers up on the International Space Station now for 20 years. You can see the space station go overhead over Central Texas or wherever you happen to be several times a month for several nights in a row, or in the mornings, pre-dawn or post-sunset. But a wonderful facility, the International Space Station, the ISS. And there's been a lot of activity up there, a lot of scientific advancement, a lot of technologies we have here on Earth now have been developed in orbit in the weightlessness of space. They continue to do extensive science on various topics, biology, microbiology, studying physics and material science and so on. So a lot of activity continues on the International Space Station, which again is a cooperative effort. And again, for the last decade, basically, through the 2010s, the US has been contracting with the Russians to take our astronauts up to the space station and return them. Since the US space shuttle program ended in 2011. So we've been paying the Russians millions of dollars per seat on their rockets to get our American astronauts up to the International Space Station. So another good point of cooperation between the superpowers. Here we see another example of that cooperation. Another disaster on February 1, 2003, Space Shuttle Columbia with its crew of astronauts, which disintegrated over North Texas. Very sad, tragic incident, of course. And therein we see the agreement between the Americans and the Russians to take American astronauts up to the space station. Here's a Russian cosmonaut working in orbit around the International Space Station. Can you imagine putting that suit on and going out into space? Hurtling along above the Earth at about 17,000 miles an hour, about 200 miles up above the surface of the Earth. You'd have to trust your equipment and yourself and your fellow astronauts. Here are International Space Station astronauts and cosmonauts working in space, hurtling along. Christina Koch, working on the space station earlier this year. She set a record for a female in space, 328 days. almost a year, living in the weightlessness of the space station. More US-Russian cooperation. The Russians, interestingly, of course, unlike the Americans who have traditionally splashed down in the ocean, the Russians do a hard landing. They come down via parachute and they land on the steppes of Kazakhstan. And that generally has worked very well. Not always, but most of the time. And it certainly has worked well with the US astronauts that have gone up and down from the space station. So here you see a scene out on the remote rural steppes of Kazakhstan, and the capsule has landed with its load of astronauts and cosmonauts, and there the Russian military coming out to retrieve them all, including a US astronaut. After being in orbit for many months, apparently your bones start deteriorating and your muscles because your bones, your skeleton is used on Earth to, fight gravity and move you around. In the weightlessness of orbit, you don't really need your skeleton. So the bones start deteriorating. And so they have to do all kind of countermeasures with diet and exercise to keep up a strong muscular skeletal structure in orbit. And of course, this is a serious consideration for longer space travel when we go not only to the moon, but on to Mars, moons around the outer planets, Jupiter and Saturn, possibly much less to the stars ad astra. So we're learning a lot as we have gotten off the planet here in our lifetime, and we're learning how space, how we respond to living in space. More Russians and Americans cooperating on the International Space Station. We are now moving into a new era of space where we have traditionally, of course, NASA has worked with private companies, contractors, Northrop Grumman, Boeing, General Electric, just an endless stream of contractors have helped. Martin Marietta have helped, build the systems, the rockets, and so on that NASA uses traditionally to get astronauts into orbit. Now we're actually seeing the private industries, the private companies such as SpaceX and other organizations build their own rockets, their whole systems. And indeed, on May 30th, 2020, earlier this year, SpaceX, who's headed by Elon Musk, they sent up, finally got America back into space with Robert Behnken and Douglas Hurley. They went into orbit, which was very dramatic. And they went up to the international, well, they just went up into orbit, but coming up here, we're going to send some astronauts on these SpaceX rockets up to the International Space Station. So we've entered a new era where we have private companies, contractors, taking us into orbit. SpaceX splashes down in the Gulf of Mexico in August of this year, and we see the capsule being brought on board a recovery vessel in August 2020. So just a couple months ago, this whole new era of manned space flight for American astronauts. There's Hurley and Behnken in there. And finally, NASA is moving toward a whole new space launch system with a heavy rocket to the moon and Mars. And we're going to be looking at this coming online in the next few years. So as the Russians continue their program to go to the moon and beyond, the US continues also in an international effort. The Russians have their OBSEC program to build a new generation of space station. So there's the whole space race continues. robustly here in the early 20th century, 21st century. NASA has signed what are called the Artemis Accords for the peaceful uses of space, operations, emergency assistance, and so on. So the space race continues, and cooperation is really more the keystone now than the competition of the 1950s and 60s. That ends our program here today. Thank you for your attendance, and I hope you found this interesting. It's an ongoing drama of human beings trying to get to space and cooperating and competing with each other. Just an incredible story of human beings per aspera ad astra, through hardships to the stars. Thank you very much for your time, and I hope you all continue to do well in your facilities and your centers and with each other. We'll be in touch. Michael Albrecht, signing off. Thank you. Bye-bye.